Now we've got a rather difficult example, or not difficult, but it contains a kind of new idea. Okay, so let's start. Find the first six terms. Okay, we want u 3.3 recurring. Okay, now we have described the sequence. Now first, let's understand it. Okay, we have this sequence. UR equals 3 plus R times 2 over R. Okay, now let's understand this a little bit, okay? First thing we will notice is that we have an alternating sign. That is the -1 to the power of R. As we explained previously, this just alternates the sign between odd and even. Odd is negative, even is positive, okay? And the 3 here, it's like the number that it converges. Okay, you'll see now. So, or like it's the constant number. So we know we have 3 as a constant number, okay, that will not change no matter what our changes, okay? And we have these two terms contain R. Now, as R change, okay, depending on whether it's even or odd, it will change the sign of this. And as it grows, this will go down, okay? So we have two things going on here. We have an alternating sign and we have a decreasing R, meaning that here the first question will be a very good one in order to visualize it, okay? So we have u1 equals 1, okay? And we have u2 equals 4. We have u1 equals 1. And we have u2 equals 4. Then we have u3 equals 2.3, recurring. We have u4 equals 3.5. We have u5 equals 2.6. 2.6. We have u6 equals 3.3. So as you notice, it's coming closer and closer to number 3. The odd terms are getting closer from like under it, you know, like 3 is here. The odd terms are getting closer from under it, okay? Like 0, 3, infinity, okay? They're getting closer to 3 from under it, while the even ones are getting closer to it from above it. So we can clearly see that as R tends to infinity, what are we supposed to see? Let's discover. So if R equals infinity, this will be 3. Now, why is that? Because, of course, we have this term multiplied by this term. And as we said, anything that has an r in its denominator and this r tends to infinity, this term will tend to 0. Because, like, think of it logically. If you have 2 over 10, it's like 0.2. What about 2 over 1 million? It's 0.00002. What about 2 over trillion? It's less than that. Now, what about 2 over infinite? It's 0, okay? This is why we treat this term as 0. Therefore, it will tend to go to 3. Therefore, this is now the answer for the second question is that it basically is a convergent number. It's an oscillating and it's convergent sequence. I meant not number, because it oscillates. It oscillates below and above number 3, and of course it converges as we saw to number 3. UR tends to 3. Okay, so for the third one, find its limit where it converges. And of course, we've already found it, and it is 3. Okay? And for the fourth question, does it reach its limit? Think of it logically. If R describes the n, the natural numbers, can it possibly reach infinity? The answer is simply no. So can it truly reaches its limit, which is 3? No. The answer is no. It will get very, very close to it, but will never. So this was the question, and thank you.